Chapter 7, Business Statistics. We're only going to cover the first few topics in statistics. We're going to start with graphs. To interpret or draw a graph, you need an appropriate label, or your title. Make your appropriate labels for your bars and your scales. Use the intervals. They need to be equally spaced and include the smallest and largest values. Draw horizontal or vertical bars to represent a bar graph data. Bars should be uniform width, which is why the intervals should be equally spaced. Make any additional notes as appropriate to aid in interpretation. So looking here, we have Corky's Barbecue Business. We have our title. We have horizontal bars here. They are equally spaced. The interval, meaning the width of each bar, is the same for each. Now, the thing missing in our bar graph would be the labels. Yes, we have January, February, March, April, May, but we need a label over here. What are we looking at? Is this all they were open for? Is this just the first half of the year? Or just months? And then down here, what is this? This is 10,000 barbecues sold, 20,000 barbecue sandwiches sold. Is this money? We're missing some of the labels. So for us to be able to interpret this graph, we need to make sure that we not only label our axes with their values, meaning this would be categorical, so the months, or quantitative, which is the value, but also what are these months and what are these values. We're going to do a similar thing for our line graph. Write an appropriate title, mark and label appropriate horizontal and vertical scales. Remember that they should be spaced evenly for your intervals. Often the horizontal scale represents time when we're looking at a line graph. Use points to locate data on the graph, and then connect your data points with line segments or a curve if necessary. Here's our neighborhood grocery daily. So we have our sales. And we have the week, again, daily, so these are the days in the week. So for here, no real label is needed. But over here, we did need to know what's 500, 1,000, 1,500. Is that customers in a day? Nope, it's sales. So on Monday, we'll have a little over 1,500 sales. So this is pretty easy to navigate through. Again, just make sure that things are evenly spaced. Circle graph or a pie chart, again, the appropriate label. The sum of the values in the data set, you do need to know that since it's out of 360 degrees, a full circle. Represent each value as a fraction or decimal of the sum. For each fraction, find the number of degrees in the sector of the circle. So your 100% is the 36 degrees. The other way that you could do this would be to make 36 tick marks around. Label each sector of the circle as appropriate. So here we're looking, don't forget your values. So this is our family take-home pay. There's our title. And then, again, to help, this could be a percent, or you can have the actual value. Both is actually preferred. So here we see, looks like a quarter or 25% of the family's take-home pay goes to housing. The other 25% goes to food. Then we have contributions, savings, and clothing are all about the same. And then we have the miscellaneous personal education and insurance, about $80 each. 7.2, now we're going to look at our central tendency. So find the mean, median, and mode. Make and interpret a frequency distribution, and then the mean of grouped data. So the mean is the arithmetic average of a set of data or sum of the values divided by the number of values. Your median is the middle value of a data set when the values are arranged in order of size. A good piece of data is when the mean and the median are very close to being the exact same number. Your mode is the value or values that occur most frequently in a data set. I do want to talk a little bit more about your mean and your median. Your median is the middle set of data. Your mean is the average. So if we have any outliers, which we're going to get to here in a few slides, outliers are a data point or maybe 2 data points that are far away from the rest of your data set. So if we would have, the average heights of, males, and then we have this 7-foot person, that 7-foot person would be considered an outlier. So they wouldn't necessarily change my median, since my median is the middle value. It's going to keep my median pretty much the same, but it would greatly affect my mean. Just like if we were looking at your exam scores. If you have all 90s and 120%, the middle value is going to be one of those 90s. It's not going to change. Your mean, however, would shoot way down because you would have 3 in the 90s and then 20%. So it would actually really pull your grade down. So to find the mean, it's a common statistic we may calculate for a data set. The statistical term for an ordinary arithmetic average. So we want to add all the values together and then divide by the total number of values. Mean. So, here's our measures of central tendency. This is what I was trying to tell you. When all of our data is, looks pretty good, we have our mean and our median should be right around the same. And for our bell curve here, the mode would also be the same as the mean and the median, and that is possible. Your mode, remember, is the frequency. Since I have this mode less than my mean and my median, that's what changes, and now my mean and my median are no longer the same value. Data sets, business records, business records, it's daily sales, and these values are an example of a data set. They can be used to observe patterns, interpret information, make predictions about future activity. With the data sets, if you've worked in, actually mostly any business would have a meeting in, the beginning of the shift or the beginning of the day and say, hey, we made $33,000 last year. Our goal for today is, $35,000. Repeated vocab. Sales figures for last week for the Western region are as follows. We want to find the average daily sales figure, which means that we want to find the mean. So we will take our sales for each day, add them all together, and then divide by the total number of days. The average daily sales figure is $3,656. So if we compare each of these values, each of the data points, to our mean, we can see Friday we did much better than our mean, Thursday we were a little low, Wednesday we were definitely low, Tuesday we were above our mean, and Monday we were above our mean. Second kind of average for a statistic is a median. To find the median, we want to order the values from smallest to largest and then select the middle value. If we have an odd number of data sets, the middle is an exact number. If we have an even number, we need to find the 2 middle values and average those together. So we would add them together and divide by 2, and that value would be our median. Your mode in a data set can be identified by counting the number of times each value occurs. There may be more than one mode if the same value occurs the same number of times as another value. However, no one value appears more than once. There is no mode. A university recruiter is evaluating the number of community service hours performed by 10 students who are applying for a job on campus. We want to find the mean, median, and mode from this data set, and then determine which one or ones might help the recruiter the most in making a realistic assessment of the number of service hours performed last semester. This is a great example because, you can find the mean, median, and mode, but how do you know which one is more helpful in your given situation? So here are our applicants and their number of hours of community service. The mean is 8.4. The median is 7.5. Here's where I'm going to stop. Looking at the mean and the median, we can see that since they are farther apart, there are definitely some outliers. So I'm going to actually look at my data set and I'm going to see that we have 20, for Jason, and Melanie has 18. So since we have 2 up there, that's not really too far out, but it's a note. However, when we look at Sheila and Art, Tony and Jackie, we do have 4 of the 10 that are quite low, which would make sense why our mean and our median were farther apart. And then we notice that the mode is 2, which again can be very telling. So of the 3 values, which one or ones would help you make a realistic assessment of the number of service hours and why? This is actually a question that I'm going to let you answer if you were the recruiter. Because, you know, as long as you can justify, you may not be wrong. Make and interpret a frequency distribution. Identify the appropriate intervals for the data. Tally the data for the intervals, and then count the number in each interval. Class intervals are special categories for grouping the values in a data set. A tally is a mark used to count the data. Class frequency is the number of tallies in that interval. Grouped frequency distribution is a compilation of class intervals, tallies, and class frequencies of your data set. So here we have test scores on the last math test. Make a relative frequency distribution using the intervals 75 to 79, 80 to 84, 85 to 89, 90 to 94, and 95 to 99. What you want to be careful of is making sure that your intervals are even. They're the same data sets. So even though it may not, if you are talking about education, you know, our grade scale may not actually be 90 to 94, 95 to 99. Because maybe our grade scale is a little skewed. You know, maybe an A is, you know, a 94 to 100, and an A minus is 90 to 93. Well, that's definitely not the same interval. So we have our class intervals. We use the ones that they provided for us. Our class frequency, so how many of these tests landed within this interval? Well, for 75 to 79, we have 78 and 77, so that would be 2. 80 to 84, we have 84, and looks like that's it, so 1. 85 to 89 would be 1, 2. 90 to 94 would be 90, 92, and there's 94, so 3. And then 95 to 99 would be 95 and 99. So count up again the last math test scores, count up how many there are. There should be 10. Your calculations would then be the number of times it occurs divided by the total number of tests. We notice that our total is 10 out of 10 or 100%, and then convert your calculations into a percent to find the relative frequency. So we can say 30% of the class scored between a 90 and 94.